Hey everyone, welcome to the channel. My name's Nader. In this video, we're going to go over the async await syntax in JavaScript. I'm super excited for this video. I've been hinting at it for a while. This is one of my favorite newer pieces of syntax in the JavaScript language. It wasn't actually that many years ago that it got added to the actual language itself. This is going to allow us to actually work with promises in JavaScript in a much easier way, kind of more modern synchronous way. I would encourage you though, if you're looking at promises for the first time and you're trying to think about async await, to actually avoid looking at async await until after you've actually studied and understood promises. Async await is just basically a wrapper of some sorts around the idea of promises to some degree. So actually understanding how promises work fundamentally is going to be super important for async await, since they just use promises behind the scenes, but only avail as kind of a new syntax to actually work with them in a more easy to understand way. So that said, let's just get right into the video. Okay, so I'd like to start the video off by kind of just setting the stage for the philosophy for kind of why we even need async and await. So if you've looked at promises before, you can probably tell that, it works really well. It's really awesome. It's a really nice way to kind of work with asynchronous code, or code that might run in the future, for example. But there are a lot to be desired as well. It's a bit hard to read. It can get confusing at times depending on how you set it up or how many promises are going at the same time. There's all this kind of extra mental modeling you need to do when you're working with promises to make sure things run correctly. So languages like JavaScript and many others have followed suit, where they introduced this new syntax called async await, which we'll look at together in code shortly. But the entire point of this syntax is to make working with promises easier. As developers, we already have so much to think about at the back of our heads as we're coding, and working with asynchronous code definitely is not the easiest task in the world, especially as it gets more complex. You kind of have to do a lot of mental jumping through hoops to figure out what's happening. So async await is really there to kind of write promise-based code in a way that we would be more traditionally used to looking at as developers, which is kind of top to bottom, right? In a very kind of declarative syntax. So when we're working with async await, just kind of keep that at the back of your mind, just so that we can kind of compare it to how we worked with promises previously. Another thing that promises really help us do is kind of avoid that deeply nested kind of .then, .catch that we have, especially if you're working with promises within promises and trying to figure out the order for all these promises to kind of work together in. So kind of orchestrating these promises is a little bit easier with async await, even though it is possible with regular promises as well. So as I mentioned, this is all based on vanilla promises. So I really implore you to make sure you really feel comfortable with promises, kind of vanilla style, before actually taking a stab at async await. Now I do want to add a caveat here that async await syntax makes it so much easier to work with promises that it's kind of that quote of like, with great power comes great responsibility. Definitely very true with async await. I've seen ample amounts of code that take advantage of the syntax. However, it actually ends up slowing the code base down quite a bit because of kind of misunderstandings in how the actual async await works with promises behind the scenes. So I'll kind of point this out during the video so we can actually see what I mean by that, but definitely be aware of how this not only makes the code easier to read, but abstracts some of the promise-based things behind the scenes, which actually makes it a little bit potentially quote-unquote dangerous, or slows down our code if we're not careful. All right, so to start, let's actually just take a look at what this is all even about. So quite a bit of code here on my screen. To start, I'd like you to focus here on the left, okay? So over here, I have a function. Okay, this function is called fetch some data. And you can see that inside of the function, we're kind of doing something that we saw in the promises video, right? I'm assigning to this variable data a new promise object that is going to resolve itself with an object here after 1 second. Okay, and all we're doing is returning that promise from this function. Okay, so the idea is that we can call this function, and in return, we're going to get back this promise object, which is going to resolve after 1 second. All right, so now the question is kind of what does this avail us when it comes to vanilla promises versus async await? So here on the right side, let's look at the vanilla promises first. We know that if we call this function, so right here, this part right here, which I have highlighted, right? If we call fetch some data, we're going to get back a promise, right? We're going to get back this promise object right here because we're returning it from the function. We know that with a promise, we can do a dot then, and we kind of give it a callback function where we can do something in the future with that result. So this would actually log out this object here with hi and error after 1 second. All right. So async await is interesting because in order to even get started with async await, we actually have to use it in the context of a function. So let's take a look at this kind of one step at a time right here. So this is the same code as the vanilla promises, but wrapped up in the async await syntax. Now, first of all, you should probably notice, even without even understanding what's happening here, it's a bit more code, right? That's true to some degree when it comes with very basic promises like this. It actually might save us some code in the long run, the more promises we end up working with. But it's definitely more readable code, especially when it's interspersed within a whole bunch of other code within our program. So that said, let's kind of read this out. So we're creating a function and we're pointing use data at this function. However, you might notice something interesting, right? In the blue, I have highlighted over here that this is tagged as an async function, and that's short for a synchronous function, which means basically not synchronous. Synchronous being it kind of runs from top to bottom, one step at a time, one after the other. Asynchronous means one thing can happen before something else, depending on kind of time or many other things. So in this case, we're saying create an asynchronous function. And inside of this function, we can do a couple of things. You can see that here, the second line, I'm assigning to a variable called result, whatever is coming back from awaiting fetch some data. So this is where things get interesting with async await. The first thing to note is that we can only use await, which is this keyword here in orange, inside of an asynchronous function. We cannot use it outside of an asynchronous function. We cannot use it in a regular function. We can't just use it in regular, just JavaScript in general without an async function. It has to be inside an asynchronous function. Okay, so these two words are kind of paired up all the time. Okay, so if we have an async function, that allows us a couple things, and one of those things is to actually use await inside of that function. Okay, so in this case, this line right here, which is kind of the interesting part, we're saying await fetch some data. So what this effectively is very similar to the .then of a kind of vanilla promise. Await will literally kind of .then the promise and unwrap the actual result of that promise. And it will actually wait for that promise to resolve. And we'll see in the kind of in a couple slides how that actually is great, but it can also lead to some issues if we're not careful. So this result is actually going to print out this object, very similar to how we run this callback function after the .then. This result is going to effectively be after the .then, if you think about it that way. So when we call this function, we should actually see this object here printed out, but after 1 second. Okay, so that said, let's just go ahead and start coding this just so we can kind of see how this works. So I'm going to pull up Visual Studio Code. I'm just going to call this async-await.js. And in here, I'm just going to zoom in a tiny bit more just so we can see this as I start coding, and I'll zoom out in a second. I'm going to actually work with a promise to start, and then I'm going to use that promise in various ways within all of our asynchronous code using async await, so we don't have to keep recreating different promises. So I'm just going to do this. I'm going to say const, let's just call it timeout instead of set timeout. And I'm going to assign to this a new promise. And promise we know takes resolve and reject. And we're going to give it a function. So inside of here, I'm going to do set timeout. And inside of this timeout, what I want to do is I want to give it some timeout number here. So I'll kind of give it that number in a second because I'm going to modify this function slightly. But I'm also going to call resolve, and I'm going to just say all done, just like that. Okay. Now, what I want to do is I want to make this easier on myself so I can show you a couple of cool things with promises. So I'm actually going to wrap this inside of a function. that returns the promise, very similar to I have right here. Okay, so what I'm going to say is I'm going to say const like make timeout, for example, and this is going to equal to a function just like this. Okay, and what I'm going to do is I'm going to return the timeout object, which in this case is a promise object. But the reason I want to wrap this in a function is I want to allow myself to give it a number of milliseconds, okay, ms. And I'm going to actually pass that I'm going to be giving it as an argument to my, oops, not right here, sorry. Where is it? Set timeout right here as a second parameter to my set timeout function. Okay, so for example, if I was to give this a make timeout, I could call it with 1,000, but then I can also call it with 2,000. And then that 1,000 is going to go right here, and we're going to get back a promise that resolves after that amount of time. Okay, so this function's job is to return to us a constructed promise that resolves with the all done message after that many milliseconds that we provided it as a function argument. All right, so I'm going to just collapse this so we don't actually have to worry too much about it and just assume that we have this function. And as we're working with this, I just want you to be kind of aware, right? Like this make timeout for now is just for us as we're learning. Eventually, we're going to work with functions that pretty much work the exact same way, except they're going to be doing things like fetching data or going off to get some data from our hard disk or something like that. And they will effectively work the same way, where they will return to us a promise once that kind of activity that we've asked for is complete, whether that's kind of going across the internet to get some data or just going down to our hard drive to fetch it locally. Okay, so let's just see how this works. So just to prove that this actually returns a promise to you, I want to console.log the result of calling make timeout with 1,000. Okay, so I'm going to pull up my terminal here and make sure I'm in the correct folder. I'm just going to zoom out a little here so I have a bit more space. I'm going to run node and I'm going to run make timeout. Oops, sorry, async await. Got confused. And you can see that we get a pending promise. Okay, and if I do this kind of a second time here and maybe give it another timeout, we can see that we will get 2 pending promises. Okay, and this will take 2 seconds to run. This one will take 1 second to run. Okay, perfect. So I'm just going to clear that off. So now we come to the async await syntax. I want to kind of put these side by side so we can see how this works. If I do make timeout like this, so I call the function, and let's say I call it after 1,000 milliseconds, I can then do a .then on it, and I will get some result, and then I can console.log out that result. Okay, so what we're going to see here is 1,000 milliseconds are going to pass, and then we're going to see the message, which is all done, printed out to the console. And just to prove that this really is working that way, I'm going to just console.log out here. I'm going to say program starting, and then I'm going to say console.log down here, program complete. Okay, now before I run this, I'd like you to think, what is going to be the order of prints? The only other string that we're going to see is this all done string. Okay, what is the order with program starting, all done, and program complete? All right, let's see if you're right. So if we run this code, we see program starting and program complete right away, and then we see all done. Okay, so kind of weird, right? That's not really what we'd expect, because this is happening first, then this is happening, then this is happening. But in fact, this is what's happening first, this is happening second, and then finally, this is happening third. So this is how promises work. We saw in the promise video. Just be aware that this kind of is the expected behavior. Now, how do we turn this into an async await function? So we have to have this make timeout, which is a promise. If we want to use await with it, we have to have it inside of an async function. For example, I cannot do this. I cannot make timeout 1,000 and await that. Okay, so for example, if I try to do this, const result is equal to that, and then I console.log this result, right? Just like that. If I try to do this, let's just see what actually ends up happening. So you can see that I get a syntax error. Await is only valid in async functions and at the top level bodies of modules. So let's ignore this module thing for now. Just be aware of this part here. Async is only valid in async functions. Okay. So let's make this an async function. So I'm going to just say const, let's just call this fetch stuff. And this is going to be a function like this. I'm going to take this code and I'm going to move it inside of this async function. Now, you can see that I'm getting an error from JavaScript, which is helpful, or my editor here, saying that, did you mean to mark this function as async, right? And I did. In order to do an async arrow function, you put async, just like that, right before the arrow function. So we're saying that effectively, if you were to read this kind of out in English, we're saying create an asynchronous function. Okay, that's the way to think about it. And this syntax would work the same way for a regular function declaration using the function keyword as well. So async function. Perfect. So now what's interesting here is that we can actually use await, and we can await this make timeout result. So what this is going to do is this is going to go off and it's going to set that timeout, and it's going to literally wait for that result before it puts it inside result, and then we're going to be able to use result after. So this is going to be something I'm going to show you in a second visually through kind of a code outline, but I just want you to be aware that this is actually the exact same code as this right here. The only difference is we actually have to call this function, because just declaring a function like this doesn't actually kind of do the function body. In this case, we actually want to call it so that we can actually execute the code inside of this function. So we should see all done being printed here after 1 second, as well as all done being printed here because we're calling this asynchronous function after 1 second. So let's see if that's true. And there we go. We get both of the all dones printed out. Okay. So here I'll just say that this is from promise, or I guess I'll just say from the .then. And over here, I'll just log out. This is from async function. Okay, and I'll just run that one more time just so it's super clear that these do happen from the two separate functions. All right, perfect. I hope that makes sense. What I want to show you though is something interesting, right? If we forget the await keyword and we just do const result equals make timeout of 1,000, before I run this, I'd like you to think, what should we expect to see here in the result? Okay, so we're not awaiting this now, right? We're just assigning the result of this directly to result and logging out that value. Let's take a look. So it looks like we get a pending promise. Okay, we're getting a pending promise, and that's because we are just calling this function and we immediately return this promise here, which is pending because it doesn't resolve until 1 second later because that's what we asked it to. Okay, so just for sake of example, I'm going to change this to 2 seconds. I'm going to put the await back in here. I'm going to watch the order of this very carefully again, just so you can see how this works. We're going to see that. We're going to see the .then and then the async function complete 1 second later. Okay, and if I make this happen first, for example, 500 milliseconds in the async function, we'll see that happen first, and then the .then happens right after. So main thing, keep in mind that the async and the await keywords always go together. Await basically is the .then equivalent of the async function syntax. And we still need to call the function because an asynchronous function declaration doesn't actually execute the code inside the body. We actually have to call a function to do that. However, we can call the function multiple times, right? So if we do it this way, for example, you can see that we're actually going to be having 2 of those promises being created from the async function and then 1 for the .then. Okay, cool. So if we go back to my slides here, I just want to show you kind of the order of this, right? So kind of based on everything that you saw, I'd like you to kind of take a look at this code here. And assuming fetch some data is just something that returns a promise. So it's something that happens in the future. Don't worry about the actual timing of it because it's not really relevant. I want you to think, what is the order of the console logs that we're going to see in this code? Okay, so once you've given that a shot, this is actually what's ended up happening. We're going to declare this asynchronous function, but we're not going to run anything, right? Because declaring a function does not execute the code inside the function body. Then what we're going to do is we're going to console log program started, which happens right away. So this is technically the start of the program. I guess you can think of it that way. We're going to call our use data function, which is going to come inside here. Then it's going to immediately log out console log, second log that we see. Then we're going to create this promise, right? And we're going to wait for it. So the program is literally going to pause inside of this function and continue running the synchronous code outside of the function. Now I'm going to say that one more time because I think this is one of the most fundamental things to understand with async and await, and where you can run into a lot of issues. Whenever we have await inside of an async function, the program is literally going to pause at that point. It is not going to continue down here to execute the rest of the code inside of that function, no matter what, until this awaits either resolves or rejects. Okay, what we can do though is run code outside of that asynchronous function. Okay, so since this console log down here, or in any other looping code or whatever code we have down here, function calls, we can run that code while we're waiting for this result to come back to us. Okay, so that's why we see this all done being printed out as the third thing. And then finally, when fetch some data returns, even if it's after just 1 millisecond or 1,000 milliseconds, it doesn't matter. When that finally resolves or even rejects, we're going to be able to come to this console log here, which is number 4, and actually log out that data that we get back from the promise. Okay, now I think this is probably one of the most important slides to keep in mind when you're thinking of promises. If you can kind of wrap your mind around what's happening here and just sit here and even just write it out or write a couple more examples and prove it out, and we'll see this in a second together, it will go a super, super long way to prevent any bugs and issues that you'll have with asynchronous code in JavaScript as we get to more complex examples. All right, so that said, we're going to go over one of those examples together in a second, but I do want to show you this interesting kind of caveat for async functions as well. If we return something from within an async function, the return value is always 100% of the time going to be wrapped inside of a promise object. Okay, so very similar to how when we return something in a .then, right? So for example, if I did a .then here, and then I did another .then, and then inside of this .then, I did a return of hello, this hello is actually going to be returned as a promise. Okay, so this is going to be effectively wrapped inside of a promise object and returned as a promise with the string hello that's resolved inside of it. So similar with an async function, whatever we return from the function is actually going to be wrapped as a promise. So in this case, if we saw our fetch some data function returned this object right here, this object would be kind of wrapped in a promise so that we could actually use other awaits on it in the future, or use .thens on it in the future as well. This is what allows the idea of promise chaining, as well in this case of like await chaining, I guess you can say. Okay, so definitely keep this in mind as well, and we'll look at an example shortly. So the first thing I want to show you is actually how we can kind of run into some issues with functions actually pausing. Okay, so I'm just going to create another file here. I'll just say pausing.js. I'm going to actually copy over my make timeout function here. And I'll just minimize that. And I'm also going to copy over just program starting here because I don't want you to watch me type this out, as well as program complete, just so again, you don't have to watch me type this out. Okay. Now, what I want to do is I want to create an async function that is going to make use of this timeout. So I'm going to say const, I'll just call it fetch data. Now this is going to be a function, an arrow function. I'll just close this off so we don't get distracted. I'm going to make this an async function, and now I can use await inside of here. So let's say I want my first result, I'll call it result 1, is going to be awaiting the make timeout of, let's just say 2000. Okay, 2 seconds. So what I'm going to do inside here is I'm going to say console.log. I'm going to say fetching first set of data. Okay. And then what I'm going to say is I'm going to say console.log fetching second set of data. And I'm going to basically do the same thing here. I'm going to say const result2 is equal to await of make timeout, and this is also going to be 2 seconds. Okay. And then what I'm going to say here is console.log done fetching data. All right. So I'm not going to actually use these variables yet. Actually, maybe I'll use it. Let's go ahead and maybe put that in this console log here. I'll just say result1, and over here I'll say result2. It doesn't really make sense with my statements, but that's fine. We'll at least see the results that come out of those promises. Now I'm going to call this function. My question to you is kind of twofold. First question, right? And I really want you to think about this deeply because this is a great interview question, for example. What is going to be the order of logs that we see inside of this code? And the second question is, approximately how long is it going to take for this code to complete running? Okay, so that said, let's go ahead and come in here and we'll say node. I'm going to say pausing. So what we want to see is we're going to see this logged out first. Okay, then I'm just going to get rid of this comment here. Then we're going to call this function, okay, which is going to come here and it's going to execute the body of this function. This console log is going to happen right away, right? Number 2. Then we're going to ask, go out and wait for this timeout of 2 seconds and then store that result inside of result1, right? So result1 is going to point to the string all done, but only after 2 seconds. So JavaScript is not going to sit there and just kind of dilly-dally during those 2 seconds. It's going to actually come back out of the async function and execute any remaining synchronous code that needs to be executed. So we're actually going to see this logged out right after. Okay, program complete. Then this is going to resolve and we're going to get our fourth log right here. Then we're going to literally pause the function again and see if we can run any synchronous code. In this case, we don't have any synchronous code left to run because this was all we had left. So we just kind of chill and wait around. Okay, and when that resolves as well, we will finally see this logged out. So let's take a look at this. So program starting, fetching first set of data, program complete, fetching second set of data, all done, done fetching data, all done. All right, so just the same order that I just kind of walked through. I hope that makes sense. Now, this is the thing that I hinted at when I said with great power kind of comes great responsibility. You can notice in this case that literally the program is going to pause at this line when we see an await. Now, the question we always need to ask when we're using things like async await syntax is this other await that we have inside of this function like reliant on this await to be complete? Okay, so another way of thinking about this question is, do we need result 1 in order to do stuff for result 2? Right? If the answer is no, these two are totally independent of each other, then why are we waiting kind of serially, right? Like, why do we wait 2 seconds for this and then wait 2 seconds for this when we could have maybe done them both at the same time at the start and just waited 2 seconds in total instead of the 4 seconds that it currently takes to run this code? Okay. Now, this is only true in cases where things are independent of each other. If we needed the result 1 in order to use result 2, then this code would not be able to be shortened because we have to have this result first. But it's really important to be aware that this literally will pause the code. So this function is going to take 4 entire seconds to run. And maybe that's fine and what you expect, but maybe it's not. Maybe it can be shortened to half that time if we don't actually need to await this. Now we can use constructs like promise all, for example, to actually make this work. So I can show you how that will work really quick. So if we were sure that these don't actually need to be like independently resolved, or we don't need result 1 inside result 2, well, we can just leave them as regular promises. Okay, so for example, if we do something like this, where we have make time out of 2000, make time out of 2000, this is not going to pause the program. This is just going to give us back a promise that is going to take 2 seconds to complete. We immediately are going to run this. Immediately we'll run this code down here. And what we can do is, well, in this case, for done fetching data, we can say const final result is equal to await, and we can use promise.all, which we saw in the promises and promise exercise videos, and we can give it an array of promises like this, result 1 and result 2, and we can log out final result right here. Okay, so this is going to return to us a promise that is going to resolve when all of the inner promises resolve themselves. In this case, we're going to fire off this 2-second promise, fire off this 2-second promise, and we're going to wait 2 seconds for this promise to resolve, and then we're going to await it, which means unwrap the actual values. We're going to get back an array of the 2 all dones. So the order of this is actually going to shift. So if I rerun this code, let's take a look. So we can see that we have program starting, which makes sense. Then we see fetching the first set of data. However, right away, you can see that we actually continue inside of this code, because now this code all the way up until here is synchronous code. We don't have any async code in here yet. The only async portion is right here, where we're awaiting the result of this promise all. So when we're actually logging out this promise here, which is result 1, it's a pending promise. Okay. The program jumps out here as soon as we hit an await, which is on line 18 in my case, which is why we see program complete. And then only when those 2 promises complete do we actually see the final result with the actual values of both of those things. Now, again, this only works in the case where these things are actually independent of each other. All right, so the next thing I want to go through is actually how we can see promises being returned by the async functions. So let's go ahead and create a new file, and let's call this return.js. So as I had here in this example, I showed that everything that gets returned from an async await function, or I should say an async function, actually gets wrapped up in this promise, right? So let's see how that actually looks like. So let's do const, for example, fetch data. Now I'll make this an async function, and inside of here, I'll just close this off for now, just so we have a bit more space. I'm just not going to use any await in here. I'm just simply going to return, let's just say I return the value hello. Okay, just like that. So I'm returning a string in this case. Now, what I want to do is actually call this function and then log out what I get back as a result of calling this function. So I'm going to say const result is equal to calling our fetch data function, just like this. Okay. And what I want to do is log out the result. Now, I want you to think, what is this result going to be based on what I just said about things getting wrapped in a promise? So I'll bring back my terminal over here, clear it out, and I'll run node and I'll return.js. Okay, moment of truth. And there we go. So in this case, I'm actually returning a promise that has been successfully resolved with hello as a string inside of it. Okay, so this is already a kind of pre-resolved promise. It's not pending because we didn't actually have any kind of timeout or any kind of waiting going on in this case. However, it is still a promise, right? So it's still wrapped in a promise. So the way that we would get this out, for example, out of this promise object, we could do something like result.then, and then we could get kind of the value inside of here, and we could do something like console.log that value. Okay. Now, the interesting thing here is that we don't really need to care, right? As developers, whether this gets resolved right away or whether this takes some time to resolve, the actual way to get the value back out of that promise is by using .then, or if we were to use it inside of an async function, then we could use await in front of it. Okay, so this is just one way. I'll just show you another way in a second, but just to show you, this is how we actually get hello back out. And if I wanted to say const like use hello. I can't really be creative right now and think of a name for this function. If I say async function here, and I say const result is equal to await the result of calling fetch data, and then I console.log that result. Now, if I actually call this function, what we'll see is that this is the same result as this result right here. So we should see hello printed out twice, one for this dot then, and then one for this kind of function call where we're using the await syntax. And there we are. We have both of the hellos being printed out. Perfect. Awesome. So the last thing I want to kind of go through is kind of the reason why we looked at try catch in the previous videos for exception handling, because we actually need that construct in order to actually deal with errors with async functions. So we saw that with .then, we had a .catch, and we could get an error kind of like this, and then we could console.error, for example, that error message out. Right? Now, this works really great for vanilla promises, but how can we kind of do this if you think about it in this case when we have async and await? So I'm just going to create a new file and I'll call this errors.js. I'm going to grab, where is it? This code right here, and I'll just use that one last time where our make timeout function, just so that we can kind of see how different timeouts work. And I'll put that inside here at the very top. So same thing, this will resolve after a certain number of milliseconds that we give it as an argument. But how are errors going to work with the async await syntax? So the last slide I have to show you kind of goes exactly into that. So this is how it works. We're actually going to use, inside of an async function, a try catch block. Now, I would encourage you to pretty much use this almost every time that you actually use async await functions, because there's always a chance pretty much that the thing that you're going to await might actually cause an error, and it would either otherwise crash your program if you don't try to catch that error with an unhandled promise rejection error. So in this case, we can handle that with this catch block down here. So there's no such thing as like a catch or anything like that, a keyword for that. We have to use the kind of regular exception handling built into JavaScript for all other types of errors as well. Nicely, we can actually reuse it for async and await as well. So we wrap the code that we want inside of a try block with the await functionality. And this is the line right here that might potentially cause an error. There might be other lines that might cause an error that have nothing to do with promises, but if they're wrapped inside of the try block, they'll all be caught inside of the catch block. So we try the code in here. If there's any issues, for example, a promise rejection that happens, we will end up in the catch block. Now, we went through this in more detail in the try catch video. So if that seems confusing, definitely check that video out. It'll give you kind of a good base for how to look at this code. So if we were to use this code and we, for example, rejected inside of this promise, we would be safe because we would catch it right here and error log or console error out the message instead of just crashing the program. So to kind of wrap up this video, let's take a look at what that looks like in code. So let's actually just create an async function. So I'm going to call this const cause error, and this is going to be an async function just like this, in this case an async arrow function. And in here we can actually use await, right? So I'll say const result equals to await, and I'm going to call make timeout, and I'll give it 2000 milliseconds. Okay, and then I want to console.log out the result. So we know that if I call this function right now, as we saw previously, this is going to work just fine, right? So if I do node and I run errors.js, after about 2 seconds, I will see my all done message printed out. And that's because this just resolves after the set amount of milliseconds. There's no rejection happening at all. So instead of doing this, what I'll do is I'll comment out the resolve message and I'll say reject instead, and I'll say there was an error. Okay, and now we're rejecting after that many milliseconds. Okay, so now I'm not going to change my code at all, and I'm going to show you what will happen, right? So we're going to await this promise, hopefully being resolved. But we don't currently have a construct to actually catch that promise rejection. So let's see what actually happens with our code now. So after about 2 seconds, boom, right? Our code kind of explodes and we get to this unhandled promise rejection kind of error and a whole bunch of scary looking stuff. So Super common for this to happen both with vanilla promises and async await. There's no difference at all. It just uses promises under the hood. So we need a way to kind of wait to see if there's a rejection and handle it, or catch it in this case, and actually deal with the case where there's an error. So this is what's called the happy path scenario, where we're just kind of assuming that things are going to work out and it's going to resolve with absolutely no issues, but there's always a chance that something bad might happen. So in order to actually make that work, what we want to do is we want to do a try block around this, and we want to do a catch. And here I'll just catch the error just like that, and I'll do a console.error of the error. Okay, so I'm going to say try to do this code in here, and if there's any issues, just immediately jump to this catch block. Okay, so just to kind of prove to you that this is going to allow our code to continue, I'm going to log program started, and I'll kind of copy that, and I'll call this program done. Okay, so we would never reach here if we didn't have a try catch block. So let me rerun this code, and we'll see that we see program started and program done right away, and there was an error. So actually, I even got confused kind of explaining this because this is actually pausing the function, so we would actually always see this printed out no matter what. But in this case, we are actually catching the error, and this line right here of there was an error is what's actually being printed out here in the console.error message. So this is coming from line 17. And to really show that, technically what I should have done is done a console.log here, and we say we are in the error case, all done. Right, so the program done should technically have been here in this case. You see, I even get confused all the time with the asynchronous code. And we're gonna jump into there, and we get the error. Okay, and if we change this to resolving again instead of rejecting, so I'll comment back in the resolve just to kind of show you for matter of completion, and we do this again, then we're gonna end up inside of the block right here, where we're actually gonna execute all of this code, including logging out the result, which is all done. And we will not end up executing anything in here. So the biggest takeaway here is we use a regular try-catch block, which we use in exception handling all over JavaScript to handle errors in the context of async and await, because we do not have a .then or .catch like we do with vanilla promises. This ends up being quite nice because it kind of fits in with the rest of the language. However, we also have to be aware of scoping issues, which we looked at with try and catch as well. So if we need access to, for example, result, maybe inside the catch block, or even down here, then we would need to make sure that we declare it up here, for example, kind of like this, and then we could assign to it down inside the try block. All right, so I hope this video was valuable. I know there's quite a lot to unpack in there. Definitely rewatch a few of the parts here because it's pretty meaty, and this is going to come up over and over again as we deal with things like databases and servers and front end and back end. So definitely make sure you have a good kind of understanding of async await as well as vanilla promises and how they kind of build on top of each other. If you did enjoy this video and you found it valuable, I'd love it if you could like the video and subscribe to the channel. As well, I'd love to hear in the comments kind of any issues you've had with async await or promises in general, and kind of what you think of this try catch using them with async await. Do you like the async await syntax or the promise syntax? I think what most of us will probably see is that we'll try to use async await as much as we can, as long as we understand kind of the caveats and kind of the pitfalls that we might run into with things like functions taking too long. So that said, what I've done in the next video is to create a bunch of exercises for us to go through async await syntax together in there, so we can kind of get even more practice with this idea, just so that we can really hammer it in and make sure we're in a good spot when we see this pop up all over the place in future videos. So I can't wait to get to that video. I'll see you there.